Welcome to another Mathnificent conversation featuring evaluating expressions. It's your nerdy math bestie Lex. Grab your pencils and let's go. Before we get started, we're going to start with our background information, which I like to call mint green tea. So as a reminder, variables are letters used to represent something that changes. That's why the root word of variables is varies, because depending on what the variable is defined as, it can be more than one thing. When evaluating expressions, we're going to substitute the given values. Sometimes there's more than one variable. That's why that's plural of the variable into the expression. Once all variables are substituted, then we just follow order of operations to simplify. So let's look at some examples. Before we take a look at some examples, let's go over a little Turks and chaos, which is what I call common mistakes or misconceptions that students make. First, the difference between an expression and an equation, because they are two different things. Expressions are things that can just be simplified. They are a series of operations that, when performed in the correct order, simplify to a smaller expression. For example, if I had x squared plus 3x squared plus 5x plus 3 plus 2. This is just an expression. I can combine some like terms. These can be combined. These can be combined. And then when I'm done combining, I'm just left with a smaller expression, a more simplified expression. Equations are solved. There's an equal sign present, and inverse operations have to be performed to isolate a variable. An equation is basically stating for some value, these two expressions are equal. So for example, if I had x squared plus 3x plus 5 equals x minus 3. This is now an equation, and I have to perform inverse operations on both sides, and I'm going to end with something like x equals whatever value makes those two expressions equivalent. So a lot of the times when students are simplifying expressions, I'll see them start minus 2, minus 2. There's no equal sign present, so we're not doing inverse operations. Expressions are just simplified. You perform the operations that you can. Equations are solved. Now we're going to look at some evaluating expression examples. Given the expression negative x squared plus 2x minus 5, evaluate when x equals negative 1. Now, if you are really good at this, you don't need to do this first step that I'm going to do. But if you find yourself still making mistakes, when you see that negative hanging out in the front like that, I want you to change it to negative 1 so that you can see that it's negative 1 times x squared. Now we're going to go ahead and substitute in negative 1 everywhere we see x. So I have negative 1, then now I have negative 1 squared plus 2 times negative 1 minus 5. So everywhere I have an x, I've substituted in negative 1. Now I'm going to follow my order of operations. I don't have any groupings or parentheses. Remember, parentheses around a number just means multiply. So no parentheses or different groupings. Now we move to exponents. Negative 1 squared. Remember, negative 1 squared is negative 1 times negative 1. which is positive 1. So now we have negative 1 times 1 plus 2 times negative 1 minus 5. Okay, we've taken care of all the exponents. Now we move to multiplication and division. I don't have any division, so remember they're together anyway, so we move left to right. So we multiply negative 1 times 1, which is negative 1, plus 2 times negative 1 is negative 2, minus 5. Now I'm left with addition and subtraction, which we perform left to right. Negative 1 plus negative 2, negative 3, minus 5, and negative 3 minus 5 is negative 8. So we have evaluated this expression. When x is equal to negative 1, this expression is negative 8. Given the expression, x minus 5 all over x cubed plus 2x squared minus 8x plus 1, evaluate when x equals 3. So we know we're going to start by substituting in 3 everywhere we see x. So remember from order of operations, fraction bars are just groupings. So we treat the numerator like its own grouping and the denominator like its own grouping. So in the numerator, we just have 3 minus 5, which is negative 2. Now the denominator, we start over with correct order of operations. We don't have any groupings in the denominator, so we go straight to exponents. 3 to the third power is 27, plus 3 squared is 9, minus 8 times 3 plus 1. Exponents are done. Now we're on to multiplication and division. The first multiplication and division I get to is 2 times 9. So we still have negative 2 at the top. 27. 2 times 9 is 18. And the next multiplication we get to is negative 8 times 3, which is negative 24 plus 1. Multiplication and division is done. Now we're on to addition and subtraction. We move left to right. 27 plus 18 is 45. We can combine those, and that's going to be 45. And then 45 minus 24 is going to give us 21. Plus 1 is 22. So I just went left to right in adding what's left in the denominator. As you know, we never leave anything unsimplified. So negative 2 over 22 is 2 times 11. We have a 2 and a 2 that's simplified to 1. So our final simplified answer is negative 1 over 11. Given the expression, the quantity x minus y squared plus absolute value of 18 minus x divided by x times y, evaluate when x equals 6 and y equals negative 1. We've got two different variables going on, an x and a y, and we have two values for those variables, so we're going to substitute them both in. 6 minus -1 squared plus absolute value 18 minus 6 divided by 6 times -1. Okay, we have two sets of groupings. I've got parentheses and I have absolute value bars. So we're going to start inside this grouping here. 6 minus -1 minus negative supercharges to a positive. So that's going to be 6 plus 1, which is 7. Inside my absolute value bars, 18 minus 6 is 12 divided by 6 times -1. Absolute value of 12 is 12. So I've got 7 squared plus 12 divided by 6 times -1. Exponent 7 squared is 49. 49 plus 12 divided by 6 times -1. Okay, now we move on to multiplication and division, and remember they are done left to right. So the first I come upon is 12 divided by 6, which is 2. So now that's 2 times -1. We still have multiplication and division. 2 times -1 is -2. And 49 minus 2 is 47. This one is a tricky one, so focus and make sure you pay attention to this step here, because that's where this one gets tricky. And you have to remember multiplication and division are one entity. They are done left to right. So 12 divided by 6 would come first, and then we multiply that by -1. We reached our last example. Given the expression 3 times the square root, 4 minus x, plus x times z squared divided by the quantity x over y. Evaluate when x equals -12, y equals 2, and z is equal to -1. So let's first substitute. So 3 square root 4 minus -12 plus -12 times -1 squared divided by -12 over 2. Okay, let's look for some groupings. We know square roots are groupings, and then we have a grouping at the end here. So 3 times square root 4 minus -12, double negative supercharges to a positive, so that's 16 plus -12 times -1 squared divided by -12 divided by 2 is -6. Finish up this grouping. Square root of 16 is 4. -1 squared divided by -6. Okay, all of our groupings are taken care of. Now we move to exponents. -1 squared is +1. So we've got 3 times 4 times 1 divided by -6. Now we're on to multiplication and division. Remember, we move left to right. So first, 3 times 4 is 12 plus -12 times 1 is -12 divided by -6. We still have multiplication and division. -12 divided by -6 is 2. 12 plus 2, and we are left with 14. Hope this was helpful. Remember, you are magnificent, you are brilliant, and I'll see you in the next video.